Welcome back to Mechanical Engineering Made Simple. Today, we're going to do something a little different. We're not just looking at a broken part, we're going full detective mode. We're treating bearing failure not as a problem, but as a mystery to be solved. Okay, let's dive right in. So first, get a load of this statistic. Billions and billions of bearings go into machines every single year. But it turns out only a tiny, tiny fraction, we're talking 0.5%, actually fail before they're supposed to. The vast majority actually outlive the equipment they're in. So failure is really the exception, not the rule.
A whole lot, actually. Every single failed bearing tells a story. It's like a crime scene, leaving behind a unique set of clues that tells you exactly what went wrong. So in this explainer, we are going to be the detectives. We're going to learn how to read those clues, figure out the root cause, and, most importantly, stop it from ever happening again.
Now, to solve any mystery, you have to know what normal looks like first, right? Before we can spot the signs of a failure, we need to understand what makes for a long, healthy bearing life. Think of this as the bearing's perfect alibi, when everything's going right.
And really, it all boils down to these four things. Proper storage, so it's protected before you even use it. Correct mounting, to make sure it's installed perfectly without any damage. Adequate lubrication, that's its lifeblood. And of course, effective sealing, to keep all the nasty stuff out. You get these four things right, and a bearing should live out its full, calculated service life. No problem at all.
All right, now for the fun part, the forensic work. When a bearing fails, it leaves behind physical evidence. And luckily for us, there's an international standard, ISO's 15243, that helps us classify this evidence into different failure modes. Let's dig into the main categories of clues we'd find at our quote-unquote crime scene.
The first mode is fatigue, and you can basically think of this as the bearing just dying of old age. I mean, after millions, maybe billions of rotations under totally normal conditions, the material just gets tired and wears out. The key piece of evidence here is something called spalling, where little flakes of the metal surface start to break away.
And this image shows you exactly what we're talking about. See that rough pitted area on the raceway? It almost looks like a little crater. That is classic spalling. It's the telltale sign that the bearing's material has just hit its limit from all that cyclic stress. It's simply lived a good, long life. Now, our next category of evidence is wear, and this is a totally different beast from fatigue. Wear isn't about the bearing getting old, it's about something actively attacking it. This is damage that happens way too soon, and it's almost always caused by outside forces, usually contamination or a breakdown in lubrication. And wear leaves behind two very distinct fingerprints. First, you've got abrasive wear. This happens when tiny, hard particles get in there and just grind away at the surface, leaving it with a dull, matte look. Then you have adhesive wear. This is what happens when the lubricant fails and you get metal rubbing directly on metal. It creates this ugly, smeared, torn-up appearance. Two different causes, two very different clues.
Here is a perfect example of that abrasive wear. This raceway, it should be polished, almost like a mirror, but instead it's got this dull, almost sandblasted look to it. To a detective, this screams that tiny, hard contaminants got into the lube and just slowly but surely ground down the surfaces.
Our third type of evidence is corrosion. Now, this isn't a mechanical attack, it's a chemical one. It's what happens when moisture or water or some other nasty liquid gets past the seals. It causes rust and literally etches the bearing surfaces, attacking the steel itself and making it weak. And oh boy, this is what it looks like when corrosion really takes over. It's pretty dramatic, right? That reddish-brown gunk is a mix of rust and old, broken-down grease. The damage here is so bad the cage has been completely obliterated. This is a clear-cut case of the seals failing and letting water pour in. Game over.
So we've looked at the evidence, the spalling, the different kinds of wear, the corrosion. Now it's time for some real detective work. We're going to connect these clues to the actual root causes. So let's line up the 6 usual suspects that are behind most premature bearing failures.
So here's the key thing to get your head around. A bearing sits right at the intersection of all these destructive forces. A premature failure is almost never just one thing. It's a whole cascade. It's usually a combination of these culprits. You've got contamination, improper loads, bad lubrication, misalignment, vibration, and heat. And man, they love to work together. Misalignment can cause vibration and heat, which then cooks the lubricant, which leads to metal-on-metal wear. Our job as detectives is to figure out which domino fell first.
So let's start with our prime suspect, probably one of the most common offenders out there, contamination. And this just means any foreign stuff, solid particles like dirt or metal shavings, or liquids like water that has no business being inside the bearing.
This slide tells the whole story. It's perfect. On the left, you see the cause, that dark, nasty, contaminated grease next to fresh, clean grease. And on the right, you see the effect. When those hard little particles get rolled over and over by the balls or rollers, they press tiny dents into that perfectly smooth raceway. And those little dents are the starting point for a much bigger failure down the road.
All right, our next suspect, who often works with contamination, by the way, is inadequate lubrication. And this one is a bit tricky because it can mean a few different things. It could be too little lube or even too much lube. It could be the wrong kind for the job, or maybe you just aren't re-lubricating it often enough.
And if you see this, well, that's your smoking gun for a lubrication failure. That smearing pattern is the classic calling card of adhesive wear. It tells us that the super thin protective film of oil between the rolling parts in the raceway completely broke down. Without that film, you get raw metal grinding on raw metal, which creates incredible heat and friction and just smears the surfaces together, leading to a very fast, very catastrophic failure.
So we've examined the clues, and we've identified our main suspects. The last step in any good investigation is, of course, to close the case. And what that means for us is using what we've learned to come up with a specific, actionable fix to make sure this never, ever happens again. Think of this chart as your detective's handbook. It connects the clue directly to the culprit and then to the solution. You see indentations and wear? Your culprit is contamination, and your fix is better sealing. You see spalling, but only in one little spot. Suspect misalignment, and go check your shaft. You see smearing and discoloration from heat. You need to look at your entire lubrication strategy, the type, the amount, everything. This is how failure analysis leads directly to making things better. And remember, these culprits love to team up, so fixing one thing, like your seals, can prevent a whole chain reaction of problems.
So in the end, we shouldn't be afraid of that little 0.5% of bearings that fail. We should be learning from them. Every single failure gives us a precise blueprint, a set of instructions on how to make our machines stronger, more reliable, and more efficient. It's an opportunity. That's it for today, Design Junkies. If you're getting something out of this, follow the podcast, leave a review, and don't forget to check out our YouTube channel.